Large language models, as powerful as they are, they can't do everything on their own. They're going to have to reach out into other data sources, and they're going to have to learn how to use other tools to be really effective over time. So one of the things we have to learn how to do is build prompts that can allow the large language model to essentially reach in and query new information, to use other tools that can help it do reasoning or computations that it fundamentally is not designed to do. And so how do we go about doing that? So one way of doing that is with an approach called ReAct. So the idea behind this is that we want to teach essentially the large language model how to think through a process and understand steps where it needs to go and use some other tool, to take some other action outside of it and get the result of that tool and bring it back in as some type of computation or result that it can then incorporate. And so there's a specific way of writing prompts to do this. Now, this is similar to chain of thought prompting like we saw before. We're going to use some of those same concepts from chain of thought prompting, but we're going to expand the approach to have this concept of certain things that the large language model knows it needs to use some external tool to perform. So let's take a look at this. Now bear with me because this is a longer example. We're going to do a single example that we're going to teach the language model with, and then we're going to ask it to perform the same task. So in this example, we have a task which is calculate when I need to arrive at the Music City BMX national race for my son to be on time for his 9 to 10 open race. So BMX is a bicycle racing sport. Some of my examples lately have been around BMX. And Music City BMX is a local BMX track here in Nashville that hosts one of the big national races for BMX racing. And so one of the things is I need to figure out when do I need to show up at the track, because these are all-day, multi-day events. And sometimes you may want to figure out how late can I sleep before getting in the car and driving then in order to arrive. And what happens is in these races, you have hundreds of individual little races that are essentially like 30 seconds each. These are called motos that are run. And you want to figure out when you're moto 87, for example, well, how long do I need to wait after the start before that race is going to start? And so sometimes there's a balance there of trying to figure out when do I need to be at the track actually, as opposed to when does the race start. And so what we're going to do is we're going to have it solve this problem for us. We're going to pretend to solve this problem. This isn't actually solving it, but we're going to show you how this process works. So we give it a task and we give it an example, which is calculate when I need to arrive at the Music City BMX national race for my son to arrive on time for his 9 to 10 open race. And then we say think. I need to find out what time the first race begins. I can use a web search of the Music City BMX site to get that information. So remember, this is our example. So we're saying, here's the thought process. I need to first figure out the first step. Now you remember back to chain of thought where we're trying to have it explain its reasoning? Well, we're kind of doing the same thing. We're explaining the reasoning behind it. So we're saying, I need to find out what time the first race begins. We're explaining what we're trying to do. I can use a web search of the Music City BMX site to get that information. And then we have the next thing we do, which we say action, search, and then we give the Music City BMX website. And so action here in the search is basically a tool that it's learning to use. It's learning to use some external tool, in this case a web search. So it knows that there's certain information it does not have, and so we're teaching it, when you need information that you don't have, go and search for it. And you can search for it with a website. And then it says the result, we tell it, is all races start at 9 a.m. So then we say think. I need to find out how many motos run before the 9 to 10 open race. Motos are essentially the individual races that are going to run before that race. I can use a web search of the Music City BMX site to get that information. And then we show it again, another example of searching, assuming there's a search tool available to it, for the Music City BMX site. And then result, we show it the result. There are 30 motos that run before the 9 to 10 open race. And then we say think. I need to find out how long each moto took last year. I can use the video live stream from the USA BMX website and record how long the first 10 motos took. And then we say action video, and we give it some fake video and pretend that, hey, we were able to go and pull this video down and time something. And then result, the first 10 motos took 5 minutes. Think, if 10 motos took 5 minutes, 30 motos will take 15 minutes. The race starts at 9 a.m., so I need to arrive before 9:15 a.m. when the race starts. I will arrive 30 minutes early at 8:45 a.m. to be safe. So remember, this is our faux example. We've kind of imagined a scenario where I need to solve this problem, and I'm using a series of web searches and then watching a video from a prior year to figure out how long things took. And I'm trying to teach the large language model, in this case ChatGPT, to use these same tools to solve the problem. So then I ask it, here's the new task. Calculate what time my 36 to 40 novice race will end at the USA BMX Grand Nationals. And then I say think, to prompt it to start thinking what is the next step. And you'll notice what it does. It then says, I need to find out what time the first race begins at the USA BMX Grand Nationals. I can use a web search of the USA BMX site to get the information. Action, search, USA BMX Events Grand. So notice it's picked up on a couple of things. It's picked up on the idea that it has this tool called search that it can use to go and pull in information. You'll notice it's also picked up on the format of the URL. Now, this format I had was just completely fictitious in this example, but it's picked up that, oh, there must be this formatting, there must be a pattern behind these URLs that I can use, so I can go and search and use some knowledge of the structure of those URLs to pull in the right information. So it's learned, essentially, how to go into a web search. And then it says result. Note, as an AI language model, I'm unable to perform web searches. Please assume a hypothetical result of the purpose of this exercise. The first race begins at 8 a.m. Now, what's interesting here is if we were actually integrating this into a real system, we could have the system, whenever it sees a result, stop, pull in the actual result, put it in there, and then basically feed this first chunk back to the language model to then continue the process. So we don't actually have to worry about if it's going to fake the rest of this. We could just have it go, and we could incrementally get to each time we get a new result out that we actually need to fill in, we could go and run the web search and fill in that result. It then keeps going. It says, I need to find out how many motos run before the 36 to 40 novice race at BMX Grand Nationals. I can search, and it goes and searches on the grands, and then it has a hypothetical result. There are 120 motos. Goes and thinks again. I need to find out how long each moto took last year. I can use the video live stream, and then it picked up on the URL pattern. So you notice it's learning a lot of things. It's learning how to use the tool and how to input data in a particular format for it based on what I showed. It then says, okay, here's the result from that. And then it says, think, if 10 motos took 6 minutes each, or took 6 minutes, then each moto took an average of 0.6 minutes. Therefore, 120 motos will take approximately 72 minutes. The first race starts at 8 a.m., so the 36 to 40 novice race will start around 9:12 a.m. I need to find out how long the 36 novice race itself will take. And it goes and does that. And then it says if the 36 to novice race starts around 9:12, then it will end around 9:15. This is the approximate time my race will end at the USA BMX Nationals. And so what's interesting is that it actually ended up in the end getting slightly off track. It gave me the begin and end, so it's telling me the begin time, but it also went and calculated the end time, which I may or may not want. But the more important thing is that along the way, it followed my pattern. Up here, I taught it this concept of searching. So I had action search, musiccitybmx.com. I had another action search for musiccitybmx.com. I had an action video right here, and it learned how to use these tools, and then it's applying the exact same tools down here. It's applying search, it applies it again, then it applies video, and it's applying it using the format. So you can imagine it's essentially learning to, run a web search, to watch a video, but again, these are tools, so it could basically go and send some information off to the tool, get an answer back, and then pick up in its reasoning. Now, the way that we would do this is we would have to have a way if we're going to use this to actually, when it gets to the point where it says, here's what I'm going to do, we would stop it and go give that data to the real tool, get the answer, and then come put it in for the result. And then we would feed this whole thing back in with the correct answer as the prompt. It then hopefully will run through up until it gets another action, in which case we would go and get the real result from that tool, put it into the prompt, and continue. And we would continue down until we got to a point where we had an output. Now, a better way of doing this would be to have some way of it saying, okay, I'm done, and I should have put that into the prompt here. But this is doing basically, it's teaching it, here are some tools that you can use if you use this format. So you can go and run this particular tool and you describe the tool to it. Now, other ways to do this, you can also, if I didn't have every tool used, I could have edited this prompt and I could have had a description of each tool and the format and other information that it could use to help it figure out which tool to use. Now, in my simple example, I did it just based on giving it patterns that I had directly in the sort of the few shot examples that I provided. But you can also have other ways of sort of catalogs of tools and their descriptions so it can think about which ones to use at the appropriate time. And you see how it's beginning to reason and know, which tool do I need to use at which point in time to get which type of information. So you can teach it to do this sort of problem solving so you can go and integrate it with other tools, and you can build these prompts that allow it to tap into other tools. And you see this in a variety of different frameworks. There's a tool you may have heard about called LangChain, which is a framework for writing these types of automation processes. And they use ReAct underneath the hood in order to be able to go and do some of the interesting things like this that they do.